All right, so in this video, we dig into the sales Datagen stack that I've depicted here on the top of this slide. And so what this does is this is a containerized application that will deploy as an ECS Fargate task. And it is going to be a TypeScript application that generates fictitious order data and publishes it to a real-time Kinesis stream. There is on the left listed the different constructs and the level of construct, and then on the right are the deployed resources. So the constructs are a Kinesis stream, a Fargate cluster, a couple of IAM roles and policies, a Fargate task definition, and then a Fargate service. Most of the resources that are deployed have similar names on the right, except for we're going to see that based off of the fact that defaults are given for the cluster resource, a VPC is going to be created for us to deploy our cluster into and the subsequent ECS Fargate tasks and services. All right, so let's dig into the code. So you can see here that my sales Datagen stack is imported from the lib directory and lives in the sales Datagen stack TypeScript file. So let's go ahead and expand the lib directory and have a look at the sales Datagen stack file. All right, so we can see at the top here, I've imported the stack and stack props from the AWS CDK itself, as well as the AWS class. I've imported the construct from the constructs package, and then I've imported the ECS construct module, the IAM construct module, Kinesis, as well as logs, and then the standard Node.js path. Defined my sales Datagen stack by extending from the base AWS stack, and I have a field level class of a Kinesis stream. Then within my constructor, I expect to get the scope of the instantiating instance. So in this case, or in the case of a stack, the scope that's passed in is always going to be an app. So we can see, if I go back to my first file, that I instantiate an application instance, and then that's what's passed in as the first scope level parameter to the sales Datagen stack. Next is a logical ID to identify my stack within the application, and then the properties to be given to it, which you can see I've given it the name of my stack, which is sales Datagen stack, as well as the environment that I want to target. Within the constructor, I make a new instance of a Kinesis data stream, giving it the logical name of sales stream, and then I create an instance of an ECS Fargate cluster. I do not give it any parameters to specify how it should be configured, and in that case, you'll find that the documentation says that if you don't provide any parameters, it's going to create a VPC with two subnets, two public subnets, two private subnets, and associated internet gateways, NAT gateways, and route tables for you. Of course, if you already have a VPC that you want to deploy to, you would actually source your VPC and then define it here, right? So all the different things that could go into a VPC, like enabling a VPN gateway, giving public subnets, private subnets, and all those other things. Instead, I have opted to go with the defaults, which will create one for me. I then define a task role, and this task role is needed so that my ECS task can write data to a Kinesis data stream, and you can see that I make that possible by calling the grant write method on the Kinesis data stream, passing it the role that I want to grant write permissions to. Then I can use that. That role in the definition of an ECS Fargate task definition. So if I instantiate a new instance of the Fargate task definition construct, I pass it the enclosing scope, which is just simply the stack itself, which is why I'm using this. I give it a logical name of task def, specify that it should have this quantity of CPU, roughly 3 GB of memory, the task role that I defined above, giving it write permission to the Kinesis stream, and then an execution role, which allows it to do things like pull container images from ECR and integrate with CloudWatch logs as well. I use all that through a AWS provided managed policy, like so. Next, I add a container to my task definition with the handy add container method. So this adds a container based off of a Docker image declaration file within the path described here. So if I go to the dir name of lib that we're inside, and then I say to look in the data generator stack, if I open that, I can see I now have a Docker file that will define how to build my image, as well as a TypeScript file that we'll look at in just a moment that defines how to generate fake data, and then some dependencies where appropriate within there, and a TS config that specifies how to transpile my TypeScript back down to JavaScript. I also feed in some environment variables that will be needed within my containerized TypeScript application, my containerized node TypeScript application, that is. One of which is the AWS region it is to be deployed in, which I can get from this helper AWS class within the core construct library imported up here. And then I also give it the name of the stream that I want to publish to, which was instantiated right here. Then I specify the logging needed. So it will use the native AWS log driver. I want to prefix my log group names with Kinesis Datagen, and I want my logs to remain for 3 days before being cleaned up. Finally, I specify a health check command that simply looks for the presence of a node process running. If I don't have a node process running, then that means my node-based container application is not running, and in which case it will realize that it's not healthy. Wrap up all of that, so the cluster and the task definition getting handed off to a Fargate service, which simply maintains the specified running count of my tasks, which by default is 1. Now let's take a look at what's going on inside of this, the actual containerized application itself. So if I open up index.ts within the data generator directory, we can see I pull in the buffer class from the Node.js standard library, the Kinesis client from the AWS SDK, as well as the put record command needed to write data to Kinesis. I define a hard-coded list of companies that I want to generate data for. So I have Hooli Corp, Acme Corp, Wayne Enterprise, and Mystery Inc. And then my available products that I'm saying that I want to make fake sales orders off of, which are Chia Pets, back scratchers, and a stress ball. Helper method that I can use to create a random integer. helper method to sleep a certain quantity of time, and then my main method. So this is the actual entry point to my application. It instantiates an instance of the Kinesis client specific for the region that was passed in as an environment variable during the definition of my Fargate task. So that's this guy right here. And then I enter a continuous while true loop. In each iteration through the loop, I grab a random customer in my list of customers with the help of my random int function that I defined right here. Similarly, I get a random product from my list of available products, and I generate a random quantity of that product. Next, I generate a sales object and stringify it based off of the JSON helper class or the JSON class, so that it has the customer, the product, the quantity of that product, and then the revenue for this particular sales order as the product of quantity and that product price. I then publish that sales item off to my Kinesis stream with the Kinesis client that was defined here, turning it into a byte array, and then specifying the customer name as the partition and the stream that was passed in as an environment variable in the definition of my task right here on the right. After each random generated sales order is published, I sleep for 1 second just to keep data generation to a moderate rate. And then I log out what I published and restart my loop again, and this will run continuously. And so that is the sales data gen stack walkthrough. In the next video, we'll look at the next stack.